by dropping out different parachute to hold drop test. You can find triple parachute coming down, a single parachute. We found that the drift was encountered by the entire structure was within 120 meters of our place of launch actually. Right, next. Yeah, this is the entire EPS, which is very important. I've told you, you have a kill switch and a LoRa module and GPS nano with 3.35 regulator and 5 volt regulator, because power supply plays a very vital role for the communication. Any voltage lesser than 3.3 volt or lesser than 3 volt does not make your LoRa communicatable actually. That was a difficulty we found in the communication actually. Also the frequency of operation, what was used in India was around 433 megahertz, and we were forced to switch the frequency when we landed at Serbia. We used 866 when we launched it at the launch site basically. Next. Yeah, you have sensors processed by Arduino, make it into a packet, send it to a LoRa, and LoRa, we have a ground station at 1 kilometer to the ground level, and it is being received once the information is acquired. Next. Yeah, this is the communication between each of the subsystem along with antenna deployment, as I've told you. Next. Yeah, a detailed circuit diagram is what we have developed. Now that this entire structure with the schematic, we are developing version 2.0, basically competing with Astronomical Society of India. We are designing satellite number 2.0, the second satellite, which will be weighing around 750 grams actually. Apart from this, we are going to make one more footprint of making one new satellite in association with ISRO basically actually. We will do that of that sort actually. It's a transmitter circuit which uses LoRa and receiver circuit. Yeah, next. Yeah, this is the team which went to Serbia, and this is the entire team holding out the drop of your satellite out there. And this is while pitching our idea in front of the jury team actually. This is at Novi Sad, Serbia. Next. Yeah, you have the rocket being launched actually. Yeah, from the ground, fuel controlled rocket at the Novi Sad aerodrome, it was launched, and while it is being deployed, we received the information from the satellite from then on actually. Right, those are the guys who were doing it. The rocket what was launched was based on two principles. One is what with pressurized pumping of your rocket so that it goes to a height of a kilometer. Other one is by means of an explosive controlled combustion actually. Two kinds of rockets they were using actually. And yeah, next. Yeah, this is about a real snapshot, and we pitched it for the novelty in design, for the novelty in the communication what we established, and for having a sustainable model, getting back the model back again. We received a special jury award from the WCRC Novi Sad team actually. Right, so I'd like to present you my team. Right, Srikanth and Kunal. Right, that's it for you. Actually, it was started as a hobby project and later developed full of students' interest, and we have spent a lot of our personal time onto it actually. Apart from their curriculum, we have done a lot of things. Thank you so much for your response. I also thank Lamakaan for helping us in building and giving us some ideas, sharing their knowledge throughout the journey actually. Right. Thank you. Can I have one picture?
Yeah. One announcement. Those of you who have not collected the fox hunt antenna, please collect it quickly. And we will be announcing the frequency for the fox hunt once we get back here. Okay, we will be announcing. So those of you who have not collected the fox hunt antenna, please collect it. And you can go and have your lunch. We'll get back immediately after lunch. Thank you.
And the team of the Nambisat design will be available in the counters. You can
వస్తుంది ఆడియో? ఏం కావాలి? వీడియో వస్తుందా? అట్లా చెప్పు నాకు.
వీడియో వస్తుంది.
ఆడియో?
ఆడియో పైదే వస్తుంది.
ఏది పై? కింద ఆడియో రావట్లేదు, చూడు ఒకసారి.
కింద రావట్లేదు.
కింద రావట్లేదు. ఇది కాదు ప్రాబ్లం అయితే, అదేమన్నా ప్రాబ్లం. ప్రాబ్లం కాదు, నాకు తెలుసు. 100% ఆడియో లెవెల్. నేను చెప్పేది అది కాదు. ఒక్కసారి నేను చెప్పేది
దీని నుండి వస్తుంది,
దాని నుండి వస్తుంది. అది ఇక్కడ నేను చెప్పేది. ఈ ఆడియో ఎక్కడ ఉంది?
కెమెరా మైక్ ఉంది, దానికి రావట్లేదు. అలా కూడా రావట్లేదు.
కెమెరా మైక్ వస్తుందా?
కెమెరా మైక్ నుండి వస్తుంది వాయిస్, దానికి అది కూడా రావట్లేదు.
రీఇన్స్టాల్ చేసావు?
నీ దగ్గర HDMI ఉంది కదా.
You make every event separate.
Yes sir, separate. Okay, done.
Otherwise, one thing only going on, right?
హలో. హలో హలో వస్తుందా? ఆడియో వస్తుందా? హలో హలో, చెక్. హలో, చెక్. 1 2 3 4. ఆడియో వస్తుందా? ఆ ఆడియో ఎక్కడి నుంచి వచ్చింది? ఓపెన్ దాంట్లోంచి వస్తుందా? మైక్లోంచి వస్తుందా?
మైక్లో నుండే వస్తుంది. దానికి
నేను డైరెక్ట్గా HDMIలో నుంచి ఆడియో వస్తుందా? సపరేట్గా ఆడియో పెట్టారు దానికి? డెస్క్టాప్ ఆడియో నాది. డైరెక్ట్ ఒరిజినల్ వాయిస్ సూపర్ వస్తుంది. మన దానికి రావట్లేదా? ఆప్షన్స్ ఒకసారి చెక్ చేయి దానికి దీనికి. అది ఒకసారి ఇన్స్టాల్ చేసావా?
అయితే కెమెరా కెమెరాకి మైక్ ఉంటుంది కదా, దాని నుంచి వస్తుంది. కెమెరా
అది నేనేది HDMI నుంచి రావట్లేదు ఆడియో. మైక్ ఏం లేదు రావడానికి. అయితే పర్లేదు హెచ్డిఎంఐ నుంచి వస్తుంది. ఆడియో బాగుంది కదా, డన్. అయితే
దానికి రావట్లేదు.
big view that is called a footprint, where it is covering, and then while traveling along its path, goes on covering whatever is the footprint area. There you will have some, that means you are in the vicinity of that particular repeater. It's a flying repeater, not a fixed repeater, but it's a flying repeater going away. So you are coming, and somebody else will hear you, and they will add you back with the same first frequency, and you will hear it back. So simultaneously, you also will hear your own communication that is called uplink and downlink duplex. AMSAT droid up, you have the 3 dots. There you can see that asks you for a Kepler updates. If you update that thing, all in the way that AOS, LOS corrections, etc., or any new satellites announced by AMSAT UK and all will come into that thing. So you'll be getting an updated information because of that thing. So now TEVEL 3 has come. TEVEL series of 8 satellites are there. TEVEL 1, 2, 3, 4, 5, 6, 7, 8. Now TEVEL 3 has been activated. That is an FM satellite. You know, fun of it, all 8 satellites will come with a difference of 10 or 15 minutes, one after another, like in a queue. Keep coming as a birds. See, because of that thing, all of them are the same frequency. Satellite, it hardly takes around 10 minutes, 11 minutes, depending on its speed and altitude, and it disappears and goes away. Within that only, you will be forced to make contacts. VU to AAP, Echo 21 EJC. Okay, good morning, you are 5-9, thank you. Okay, that is one contact. And that your interest, your energy is an expenditure, or your enthusiasm is an investment there. If that is there, you will have the subject, you will learn the subject. Without doing anything, nobody learns anything. This is what I'm feeling. So many new call signs are coming up. Everyone is, many of them are, it's a pity, taking for the ornamental purpose only, especially the engineering college students to write something in their CV. That I'm also licensed. One more thing, we are called radio amateurs. Am I correct or not? We are radio amateurs or not? Means you should have a subject interest on radio communication subject. But majority of them are coming on Echo Link and WhatsApp, and they're claiming is radio amateurs. Is this justified? Is this justified? Huh? I've been telling everyone, Ari Baba, how can you claim yourself as a radio amateur? Nonsense. You are not a radio amateur. You are an Echo Link operator. Everyone is and operating from their mobiles. Did you ever try putting up a walkie-talkie or going onto your terrace and trying through the repeater? Okay. Did you ever try putting on a small external RG58, some 2-3 meters cable and putting up one small antenna to that thing? Apart from your rubber ducky antenna, People are asking me, how can we communicate through the satellites without changing the antenna? Same rubber duckies, they want to communicate to the satellites also. How it is possible, sir? That is what I'm appealing to everyone. In 1982, when Rajiv Gandhi came here, AP Amateur Radio Society arranged the first meeting, and then they gave me an opportunity to speak. And that old days also I told, please don't keep your licenses in the cold storage. If you use them, then only it will be useful for the country. Here, today, Japan is having a lot of ham population. It is growing, regularly growing up. And India also started growing up. But there are practical hams in Japan. Lots of stations comes on, especially on the weekend, Saturday and Sunday. High-speed CW operating through the computers at 60 words per minute. They type it and then they send a CW and then receive and then displays on the computer. And China also. And so many newcomers are coming there. Is it such a pity? Only 2 operators from India operating on LEO satellites, VUT IAP and VUT LBW. What else is lacking? That is what I'm surprising. It's a great pity. That's what I'm telling. It doesn't cost you a heaven. People are asking me, it may costing a big antenna setup like automatic rotating computers, everything. Certainly not. The same thing happened with the QA100 system also. Everyone started thinking, no, you should have a GPS locking. No. I'll ask Goldman KDS, Mr. Kumar from VUT KDS from Bombay. He was also feeling like that only in the beginning, but later he understood. Yes, there is a drift because it is not locked to the GPS, but the drift is slow. He's still enjoying. He's also rotating this thing. Suppose your VFO is drifting. Nowadays, it is not drifting because it's the commercial radios. Myself and VUT OZ, like Goldman Arun, they must be knowing Farhan and all. We had that pain of frequency drifting and keeping all our tracking the VFOs always rotating along with the frequency, shifting frequency. Yes, we enjoyed the hobby in those days also. Why can't you enjoy? Having everything in hand, ready-made food. Ready-made food, that's why nobody is interested. Are thinking, okay, chalta hai, this food is available everywhere. Ready-made knowledge, everything is ready-made. But that in those days, it is a hard-earned knowledge and we did that. See, we at Lamakaan Amateur Radio Club, we are having the capabilities starting from a crystal radio to the satellites. We are always, with a lot of patience and interest, we are answering the questions and queries. We are encouraging everyone, newcomers or old-timers, anyone, those who are having any doubts or subject knowledge requirements or anything. You are always welcome to call us. Feel free anytime in LARC groups to post your queries and questions or call us directly. We will be ready to answer these things. This satellite communication presentation, and I am trying this around 5 o'clock. We have an ISS pass. Whether I can see whether I can make some stations to contact. It's a 20 degrees pass. Or if activity is available, we can make some 1 or 2 contacts to this thing. If possible, we will make a record and present it later here. See, the time, as I told you, the time availability on the satellite is very short, so the QSOs also will be very short. Something like, say, hello, so-and-so call sign, you are 5x9, 73, bye, okay. That is the contact, there's something like that. So because of the short window available, sometimes, if it is a overhead pass, you will be having a bit longer time. But if it is on the eastern horizon, or maybe some 5 degrees, 4 degrees, or the western horizons, it's on the horizons, your time will be very less. And the stations on the other side will be having only half minute or 1 minute window. But sometimes only. But that is very encouraging, interesting also, how you had a contact, how many kilometers you had. My longest contact now is 7,700 kilometers with F4 DXV through the RS-44 satellite. So now this green cube has come. That is just 1 week back, VUT LBW, Lucky from Bangalore had a QSO of 13,000 odd kilometers because its altitude is high and it is having a very large footprint. That is a digipeater actually. You send some text, it takes and then sends back on the same frequency. So that is a digital repeater. So if you come forward, what I am suggesting everyone, you go with ISS. Because of its transmitter, high power transmitter and easily available transmitter, and then strong signal with 2 walkie-talkies, you try overhead passes, you will understand what is what and all. So you go for some sort of an antenna, this thing or higher gain antennas, then you will be able to work lower angle passes and will be hitting stations and all. Then you can think of going into linear satellites and all. The satellites are there, many satellites, many new FM satellites are coming up. Working FM satellites is very easy. If you have interest, and enthusiasm, that will show you the way.
Thank you. Thank you, Amar. That was an entertaining talk. Thank you.
On behalf of Lamakaan Amateur Radio Club, Hyderabad, I'm wishing you all a happy and prosperous New Year ahead, healthy New Year 2023. We'll be seeing you all at LARC-5 next year, December 2nd. who have come across various parts of the country, thank you very much for making this event in the grand section and the belief you are having on the for the technical sessions and the good stuff available at including the flea market, available at LARC events. That's all we are trying to stand up to the expectations. Thank you very much, 73.
Thank you. Thank you, Amar. Let's give another round of applause. Thank you so much. Okay. Just before we hand over to the next speaker, there's an announcement that the US exams are going on outside. So if anyone is interested, you can take part in the US exam. You can contact RK or IPL outside. Okay? And yeah.
Good afternoon, everybody. This is a sales pitch for the lectures which are going to be taking place in the other hall. So now the homebrew kind of lectures are going to take place here, and in the other hall we have lectures for the absolute beginners, for parents, for teachers.
Thank you. Yeah, we have our next speaker, Mr. Arun Kumar. W8ARU. We welcome him. Please do come, sir. Huh? VU2 Oscar Zulu.
Good evening. I used to be a ham here in India, in fact in Hyderabad. I got my license in 1969 or 1970, and I've been a ham ever since. My first operations were from my college at IIT Kharagpur, and for some reason, I don't know what the reason was, I said there is a satellite going across called Oscar-6, and I'm going to go through it. Eventually, I did. I will share some of my experiences with you as far as Oscar-6 is concerned, as to what the hardware was. You will be surprised that absolute junk can get you through a satellite. And Oscar-6 was no ordinary satellite. I used to be on CW, and on CW, it's absolute torture to go through Doppler. But anyway, we went through that. And very recently meaning sometime around 1990, I moved to the US, and I have developed a exceedingly simple antenna rotator, which along with satellite antennas, which you just saw a few minutes back, you can track satellites for the entire duration without tiring your arms. It is so simple to make, I think you will find it interesting. I'm not sure whether I don't have very much as far as slides is concerned, but I will show you what little I have. There is the thing called India 2022. Yeah, just click on this. That's right. Yeah, and then it says satellite antenna. Yeah.
First one.
Yeah, just go through the first one. I don't have these slides in sequence, so I'm just going to go through what it is. Anyway. If anybody has used a TV rotator, a rotator which comes with a standard TV antenna, is anybody familiar with the TV rotator? Okay, what it consists of is basically a motor, which is this thing over here, and a big gearbox. The gearbox rotates the main shaft, which connects to the TV. The only problem we have is for a TV antenna, you can move it only in one direction if you use a rotator like this. So what I did was I came up with a system whereby you use the second motor, which is part of the antenna. Okay, the way the TV rotator works is something like this. It's got an AC motor, a two-phase AC motor, on a gearbox which is connected to a shaft. The shaft moves, and the TV antenna can be swiveled. But at the same time, there is another motor which is which is identical to the motor which is used inside the rotator on a knob which displays the position. So what you do is you turn another knob, and it'll start the first motor rotating. The second motor rotates in synchronism with that, and when it approaches the point which you have set, it trips a limit switch, and it shuts the rotation of the main antenna in one direction. So what I did was I took all that rubbish out, took the motor from the indicator, connected it to a bunch of gears, and then used that for tracking in elevation. I will show you some of the pictures there. Can you go ahead to the next one? These are the pictures of the motor itself. Please go ahead. Yes, just hold it there. Now you need to know the position of where this rotator is. So for that, there is a device which is what they call a digital potentiometer, this black thing over here. That is basically a magnetic pickup. The first few models I had used a regular potentiometer, but something went wrong. The potentiometer went and hit the end, and it kept cranking and cranking and cranking, ripped my power cable out, ripped my antenna cable out, and it wasn't a pretty sight. So I replaced it with this. This is available from a variety of companies. In the US, it costs between $2 or $3, so whatever the equivalent price is here. It's basically two Hall effect sensors kept at right angles and a permanent magnet on top of it. When you rotate it, you get two signals from these two sensors, and that is combined in some electronics which converts it into a 0 to 5 volts. But the point is, the rotator, the rotating portion of it and the base portion of it, there is no mechanical connection. So it can keep rotating as much as it wants, and it will not wreck anything. So that's what I used. Now, you will see a bunch of gears, plastic gears over there. They are from a variety of devices. These are gears specifically from a toner cartridge, a laser jet toner cartridge. You can select gears from wherever you want. There is a ton available in all kinds of junk. And a laser cartridge is the simplest to do because they insist that you send the cartridge back. No, you don't. You pull all these gears out and then you send the cartridge back because those fellows are only concerned about the selenium or the silicon-coated drum. Anyway, you can get gears from there. You can make your own gears, and I'll show you how to do that. Go to the next slide, please. This is the first mock-up I had. You can see the horizontal rotator. One of the rotators is over here. There's a shaft which goes through. There's a cross shaft there, and this box houses the second motor and the gears for moving the antenna in elevation. Looks a bit intimidating, but it's exceedingly simple. And at the bottom, the red box, that red aluminum box consists of a circuit board, which is quite readily available. There's a guy here called Fox Delta, if I'm not mistaken, who makes a board which can control a Yaesu type elevation azimuth rotating system. You can buy that board. I think it costs somewhere in the order of about 45 to 50 rupees for the board and another maybe about 200 rupees for the components. So it's relatively cheap, and that you can use to control these two sets of motors. Now, the motor proper is a two-phase induction motor. So people who have some inclination to dabble in electrical engineering will find that the two-phase induction motor, one phase is directly connected to the supply, the second phase is connected across the supply through a capacitor. Now, depending on which winding you use, you can make the rotator go clockwise or counterclockwise. So I have inside that plastic box which you see on top, two relays, two solid-state relays, which switch the capacitor into one side of the motor or one side of the winding or the other. Exceedingly simple, and the reason why I use the solid-state relay over there is that you can control a solid-state relay with a 5-volt signal. This LVB rotator or the Fox Delta rotator gives you a 5-volt signal to control it. It's basically, it lights up an LED, the LED switches on a triac, basically. So the LED switches on one track, the thing goes on in one direction, it switches on the second track, it goes in the other direction. And as it's moving, The potentiometer, which I talked to you about a few minutes back, that tracks its position and sends it back to the controller board, which says, okay, now you have moved 300 degrees. Your requirement was 310. Let's move another 10 degrees more and stop. Okay. So all that is controlled through the G5LB, on the G5LB board. The G5LB board, which is basically this, what is this, Fox Delta rotator card, gets its inputs in a format which is true for, which is through a serial port, and the format is compatible with a Yaesu brand controller. I'm not sure what the brand name, I'm sorry, I don't know what the model number of that controller is, but it is quite standard. It's an RS-232 interface, and you can energize that interface through a software program called SAT-PC32 or G-Predict or any one of those other satellite tracking programs. Even the AMSAT program, which you had just shown some time back, the Argentinian program, has a DDE connection to this, and that couples to this board quite easily. So relatively simple. You have this rotator, you have a PC, you have this Fox Delta card, which you can build. It just has one microcontroller. The software is available. It's a PIC microcontroller. You just have to program it, and there's just a few additional chips which will allow you to do this. You have the next slide, please. Go ahead. Yeah. This is another view of the whole setup. It's made from, you can see that the housing there is from a gutter pipe. I had a round gutter pipe. I cut it in half, made a square out of it by heating it, and then the two pieces stuck together. It's a shaft which is coming out, powers another shaft at right angles through a gearing. And I have some sort of a, what do you call that, a protractor board, which I drew in AutoCAD and stuck onto that plastic to tell you where the thing is. Next one, please. That's another view of the same thing. And it also gives you views of my shop, which has got all kinds of junk all over the place. In fact, you see two clocks over there on the wall. One of them is regular time, the other one is Greenwich time or Zulu time, for me to be happy and say, hey, this is my, I'm operating at 2100 hours Zulu, right, whatever it is. I got a drill machine at the back there. I'll show you a few more a bit later. Next one, please. This is another view of the same thing. The right angle drive mechanism is that block which you see on the left side just next to the cable, which is over here. That is from a company called Boston Gears. It's basically a drive for a go-kart. It's the rear axle drive for a go-kart. Now, a go-kart is slightly different. It does not have a differential drive. It's got a straight axis drive, and when you want to make a turn, one of the wheels slips. There is a clutch there which makes it slip. So basically, you have a right angle drive, which you see over here, and all you got to do is extend it on both sides with a pipe, and you can mount antennas as heavy as 100 pounds or 50 kilos on it, and it will rotate it quite comfortably. The gearing inside this box is sufficient to take care of that. Yes. The gearing, again, I collected a bunch of gears, steel gears and things like that from old clocks, and I put the whole thing together. It's relatively straightforward. You don't need to bother about the gear ratio as long as it is very high. Once it's very high, you know that you're going to get an excellent amount of torque. There is another alternative which I think can be very easily adapted for this purpose. The device is called a lathe dividing head. I'm sorry, a milling machine dividing head. So it's basically a chuck which rotates in one direction, and at right angles to that, there is a worm wheel. That is, those are available for a ridiculous price on eBay. In fact, I got mine for another application, which I will see whether I can pull up slides for, which costs less than about $15 in the US. Now, a commercial one, which is sold in the US, is upwards of $1,000. So in eBay, on eBay, you can get the sort, well, you get it there. I'm not too sure whether you can get it here. But here, new ones should not be very expensive. So you mount one for getting you this right angle rotation quite easily. Next one, please. Some more views of the same thing, go ahead. Now this is an indication on the azimuth rotator. Again, a protractor grating made with AutoCAD, stuck onto a piece of plastic and just dumped there. The bottom is the housing of the original antenna rotator, or the TV antenna rotator. Next, please. Okay, one more view of the same thing. Another view. Yes, this is a mechanism to indicate where it is. So it's just a lump of plastic with a line scribed at the back. One more, next. Okay, this is something else which I had worked on, another piece of scrap. You will notice that there is a brass gear on the back, the yellowish gear, which has got 712 teeth and a worm and worm wheel drive. This came out of, it is called a goniometer. It came out of an X-ray diffraction machine, and somebody had thrown it in the scrap. The scrap, it weighed about 350 pounds by the time I could get it home. Now it forms part of my drive for my telescope, which I'll show you some pictures about. Now here is where I built my first brass gear. That thing, by the way, has been made at home. A solid chunk of brass rubbed against a, I think it was a half-inch bolt, because half-inch is the standard in the US. You take the half-inch bolt, chuck it onto a lathe, hold this big disc in front of it so that it literally cuts teeth onto it, put some slurry inside, some cutting paste, and continuously rotate it over a period of about a few hours. That whole gear forms. So if you're looking for a very large gear reduction and you want to make it at home, this is one of the simplest ways of making it. And I can assure you that this gear is about a foot in diameter. So I had a solid chunk of brass that much, and I continuously chugged on it till I got a gear. It's like Picasso. Picasso was asked as to, how do you make a particular picture, a particular sculpture? He said, I take a block and remove from it what doesn't look like the sculpture. That's right. So that's how you make gears. Next one, please. Okay. This was my first attempt at making a right angle movement. That is, the motor at the back. This is the elevation drive. There's a motor at the back with a shaft coming out connected to this gear. That it's a spur gear, two spur gears meshed with each other. Exactly. These are gears from, again, this was from an old Xerox machine. So Xerox machines are, when they stopped using Xerox machines, they would throw them out. I'd go out and dig into dumpsters and then pull them out from there. This, unfortunately, was not a very happy situation because those plastic gears could not stand much torque. That's when I switched over to the Boston gear right angle movement. Next, please. Okay, this is what the antenna looks like once it's mounted. Can we go one more? Yes, this is more like it. The two antennas are angled at 45 degrees. Those, by the way, are regular antennas similar to what you have made, but each is 7 elements. And it's got enough gain and minimum bandwidth to track a satellite right from the horizon through my house. The house, unfortunately, in the US, all houses are made out of wood. So the signals go right through the wood. But this thing tracks it all the way from one horizon to the other, and I get continuous tracking periods of up till about 7.5, 8 minutes, even on low orbits. And vertically, of course, I get excellent signals on this. Next one, please. Some more? One more. These are all just multiple views. See, Farhan told me a few days back that get something together and talk about something. So I picked up whatever pictures I could have, and it's consolidated and brought here. This is what it looks like inside my basement till it's moved out. Horizontal drive, vertical drive, the antenna is mounted on. The antennas, the weight of the whole thing is about 30 pounds, about 15 kilos, 12 to 15 kilos. But I can mount massive antennas onto the thing because it can turn as much as about, the torque is enough to turn 100 pounds. Once it's balanced, it doesn't matter. Some more? Closer view of the same thing. Some more? Next one, please. I just piled up what, okay. This will tell you what we have here. This is a commercial gearbox from some instrument. I don't remember exactly what instrument it was. Again, from eBay. You keep looking at these. You say gearbox in eBay, it'll pull out 10 pages of junk. Then you look at this one, you say, 1:1700. This will work for me. Let's bring, that's how I got it. Then all the connectors and things like that are mill connectors, which you get again from eBay for peanuts. Now I have a brass pipe over there, which takes all this signals so that the gears inside do not jam. Inside that, one more. You see, there's a connector board there. There are two limit switches which are run. Since it's an elevation motor, I don't go and snag against anything. Being made, I had to clamp the whole thing and start working on it. Next. Another view. Next. 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 I don't know, I kept taking shots because I thought it was fascinating, that's all. Next. This is a little more detail, that's all. Yeah, next. Next. Oh, by the way, can you go back to one more? Yes. That big plastic gear again is from it's from a printer. It's from a dot matrix printer. It's the main drive between the stepper motor on the left side and the drum. That hooks on to the potentiometer through another gear on the potentiometer. That's why it's there. I had a 10-turn potentiometer there. So one half rotation, I want to get as much travel as possible. Now, of course, nothing of that sort is there. The potentiometer directly connects to the shaft, to the motor shaft. One more. Next, please. Next. Yes, hold this. This is on the main azimuth drive. You can see the limit switch is very clearly there. And the two gears, you see the gear on the right has a small brass pinion at the end of it, which is here. This allows the thing to hit the limit switch over something in the order of 270 degrees, so that the azimuth can swing up to 270 degrees. More than that is not required for that LVB board, because you can program it such that it takes just 180. But 270 is just to be safe that it does not rip itself apart once it's in operation. By the way, this whole thing is all covered up with plastic, and it's outside in the snow. It's been running for the last 5 years in the snow. Now, I haven't broken one cable. I haven't made too many contacts, but it's been fun seeing the thing track all on its own. Next, please. That's a slightly clearer view of the detent which hits the limit switch. Next. It's fun taking all these parts together and trying to figure out where best you can fit it. And you can do it, it's just a little effort to do it. But once you do it and it works, the satisfaction is very, very great. Well, you got to keep your eyes open. Look at eBay every day. Someday you will find something and say, that's what I want. That's right. Yeah. Next. Okay, just hold this. Yes, you see these things being thrown in the US left, right, and center. I mean, you just drive on the road, you see a printer lying on the side. No, it's got no place to lie on the side. It should be in your basement, so you take it apart and you get the maximum parts for it. I was telling you about switching the two phases with a capacitor. Those three capacitors there are AC electrolytic capacitors, non-polarized, which is sufficient. See, these motors run at 25 volts, so it's relatively safe. And those two black boxes which you see there, it says, those are the solid-state relays. They are from a company there called Opto 22, which were the first to make solid-state relays. Yes, that is correct. That is correct. So those are the two switches. They are not mechanical switches. They are, what do you call it, opto isolated switches. They're basically tracks powered by light. So there's an LED inside there. The LED, when you turn the LED on, it switches on. And it can handle as much as 8 amps of current. And they're exceedingly cheap. I mean, even here, you should be able to get, I'm not sure what the number is, but there are quite a few relays, solid-state, what they call solid-state relays. This is a solid-state AC relay, because that's all you need. Next one, please. One more. Okay, next. This is not done. Okay, these are some pictures which I downloaded, the SSTV transmissions from the ISS. So this is using this antenna, tracking over a period of, tracked over a period of more than about 4.5 minutes. Next. That's another one. So I have about 75 pictures. I just pulled out 3 from this. I think that's the end of the line. Oh, maybe. Okay, can you go back to the directory? Okay. Can you go back here? Yeah. India 2022. Yep, just click on that. Okay, now it says telescope. Yeah, just click on that. Yeah, start off with one. I also indulge in making, next one. Telescopes. If you remember some time back, I'd shown you this gear which I had cut, this thing. Now, this has formed part of a rotating mechanism for a telescope. And that's what the whole arrangement looks like. The telescope was made from bits and pieces of whatever I could pick up. Whole investment in this is about $50, which is almost nothing. The telescope of this size, I have pictures, unfortunately they're on my cell phone, of planets and things like that which I've taken with this telescope. It's a 4-inch diameter lens. Next, please. It's a closer view of that. Next. Another view. Another. Yes, this is the actual position in which the stand is kept, so that I can use a motor behind this shaft here to track any object in space. And all you got to do is switch that motor on so that the motor runs one rotation in 48 hours. And then you got a continuous track, so you can take pictures over a period of a few hours. So you can continuously track any object in space for at least 2 hours before it goes out of alignment. Next. What you see here is what I call a bore-sight telescope, which basically allows you to align the axis with the North Star. So what you do is you move the whole mechanism forward and tilt it such that through the bore sight, that bore sight is basically a small telescope. It's got a crosshair on it. You point it to the North Star, make your adjustments in azimuth and elevation so that you see the North Star. Once you see the North Star, for days on end, you will see the North Star exactly in the same position. So you know that you just have to make only one axis movement is sufficient to track. Next, please. Another view. Again, made from junk, literally bits and pieces of aluminum. Even the stand is made out of aluminum architectural sections. Next one, please. That's it? Yes. There's no more. Okay, can you go back to the directory? Is there anything else? Again, India 2022. Okay, the first one, it says Morse key. Yep. Yeah, hit that. Okay, I operate only CW. I do not do sideband. I do not do repeaters because it gets to be a bit of a bore after some time because you talk to the same guys over and over again. And there's only so much you can say. Now, of course, you got we have a digital mode over there. I think they call it DMR. No, on the repeater circuit, they've got something called a DMR. That way you can connect to through multiple user groups. You can connect to anywhere in the world through that. But that takes the fun out of it. Morse takes the fun back into your life. So I said, I'm going to get myself a Morse key. It turns out that Bengali and all those people make keys for $300, $400. So I said, I'll make one. That Morse key is made on my lathe and my milling machine with scraps of brass and bearings from a hard disk drive. These two here, which you see, this one and that one, are bearings from the head movement of a hard disk drive. So since I am the director of IT at my company, every so often we scrap a bunch of drives, and what do I do with it? Take the whole thing apart and extract whatever information I can from there. These bearings are from there. And the rest of it is machine. Normally what you have is you have a set of contacts, which you make the contacts, and the back pressure is through a spring. Here, the back pressure is through two magnets. So the contacts are here, between here and here, and this is where the two magnets are, which if you bring two magnets which are repelling closer together, you get more of a repelling force. If you move it further, you get less of a repelling force. So that's how I adjust it. I can go comfortably, and I'm not bragging, up to 45 words a minute transmitting and 45 words a minute receiving. Receiving, I make a few mistakes because I got to write it down or type it. But hey, 45 words a minute is 45 words a minute. Sorry? Yeah, please go ahead. Everybody uses it. And these magnets are ubiquitous. You get them anywhere. I mean, from anything. In fact, even the hard drive, if you take a hard drive apart, you'll get enough magnets to hold you to the floor. They're really strong. Doesn't matter. You take a laptop, remove the hard drive from there, just open. I don't care. I just take everything apart, whatever fits, I use. You just have to spin it after removing and see whether it still spins. If it spins, it's fine. Next. Next one, please. That's another view. One moment. Can you go back to the previous one? Yes. You can see the contacts here very clearly. And if you say that, oh, where am I going to get silver contacts? Okay, get yourself a bunch of old relays. They got their contacts are silver. Cut the contact out and solder it onto a chunk of brass, and then there you have it. And the back again, you can see the magnet kind of, yeah, you can see the magnet here. There you go. The magnet's right there. The fixed magnet here and the magnet on the clapper is that side. So the gap is what you adjust to get more or less repulsive force. But the point which I'm trying to make is it's so much fun making something like this than actually buying it that I hardly buy anything. I buy only junk. Next, please. That's another view. One more, and I guess that's it. It is fun, yes. Can you go back to the root directory? Yeah. The 2022, yeah. And there's a bunch of, no, IMG. Yeah, just go through one after another. Tell you what it is. This is a view of my limited workshop. I've got a CNC milling machine on the right side, lathe on the left. This was a few years back. That is It's a hobby lathe. It's from a company called, it's made in China. No. Shedline and all I cannot afford. Those are $2,000, $3,000. This was hardly $85 or something like that. Yeah. Yeah, so it's a small 7-inch lathe. The milling machine is CNC controlled. And the way you CNC control it, it started off as a regular hand-controlled milling machine. I threw the hand controls out, and you can see those stepper motors on the right side on top. The front stepper motor, the X-axis stepper motor you can see very clearly. The Z-axis stepper motor is right on top. And that big motor with the gray motor is the main thing which drives the cutting head. Next one, please. That's another view. Oh, by the way, the software on that, the software which you see on the screen is called Mac 3. It is freely available for any hobbyist. Unfortunately, the Mac 3 insists on talking to a parallel port. Now, a parallel port doesn't exist on a PC. So what you do is you get one of these controller boards from AliExpress or eBay again, which takes a USB port, converts it into a parallel port, and it works. It works pretty good. Next one, please. Yeah, next. Yeah. This is another view. Right now, okay. Yeah, just hang on. I have extended the bed of the milling machine to 12 inches, to 14 inches, so I can get better pieces. I do a lot of work for the university over there because the university workshop is very heavily loaded. So whoever has a project going over there and wants a part in a hurry, all they got to do is supply me STL drawings, and then I just put it inside the... Oh, okay. Now you asked me the right question. It's 1/100th of a mil. That is 1/100th of a thousandth of an inch. I have machined surfaces. The first time I machined the surface, you can see a face on it. The milling machine it's really good. It's got what do they call it? Rotating ball socket. It doesn't have a nut. It's got a nut inside, and there is the groove has continuous ball bearings which go right through. So, yeah, that's right. And each rotation is it's 50 rotations per inch. So that gives it additional, and the stepper motor is 1/256 step down, so that gives you even more. It works. I mean, those numbers you can add up to, but the surfaces are exceedingly good. Next, please. Okay. Like I said, I got into the satellite business in 1971, and that's an AR-88, yes. The first satellite which went up at that time was the Oscar 6. And if you look carefully, the left QSL is from VU to UV, from Subi, from Bangalore. I don't know whether he's still around. Sorry? Yeah. Right. The second QSL is from RM. You can hardly see it though. The next one is JA1DJJ. That, by the way, is a 19,000-mile round-trip contact. 19,000. Kharagpur satellite, Japan. Japan satellite, Kharagpur. And the last one which you see there, just below that was our main HF transmitter. It had two 811s on it, nearly 1,700 watts, and I could raise hell on HF. That QSL is from Delta Uniform 1 Papa Oscar Lima, DU1POL. Philip, DU1, yes. He's no longer in service, neither are the other guys. Ram is, of course, gone. But if you say Subi is around, I'm going to see him in Bangalore next week sometime. Next one, please. Okay. Sorry? That's not his, buddy. It's mine. Not the receiver, the transmitter. Okay, no, I don't know about. Okay, it's another view of the. It says Oscar 6 DU1 POL J8 DJJ VU2 UV, and the next one was VU2 RM. Next, please. This was a typical session on the Oscar. Myself right in the front. Of course, I had to do the operating because I made all the equipment. Then we had two other guys recording the thing. And as luck would have it, none of the professors there believed that I actually talked through a satellite till one of these cards came, the QSL cards came. Because they said, "You think it's a joke?" I said, "No, I've done it. It's a satellite. It's..." Next, please. This was sent to me from J8 DJJ, saying what his ground station was like. Next. Okay, here's where the fun is. That was our transmitter. The tubes which you see on the table are 829Bs. And that, where you see this QSL card which says VU2QQ, that was our final amplifier. Had 25 watts of power coming out at that time. And the exciter is behind that. Next one, please. Yep. That is the final amplifier. The exciter is sitting at an angle on this side with the crystal. I'm sorry, this was the exciter. This is the crystal. Okay, the fun part of the story is it was a crystal which was 6.7 megahertz or something like that. I had to etch it up because that was the only crystal I could get my hands on. I had to etch it up to 8.10833 so that the 18th harmonic of that was 145.95, which was the Oscar uplink frequency. Etching a crystal from 6.9 to 8.1 is no fun. No, I didn't do that. I would soak it in hydrofluoric acid for 5 minutes, take it out, wash it, measure the frequency. Sorry? That's right. Well, I didn't grind it. I put it in hydrofluoric acid to etch. Yeah, you grind it for quicker. I didn't have anything to grind it with. I had hydrofluoric acid, so I kept doing that. I kept doing that for, I think, 1 week before I got it to the frequency. And it worked. First key down, the satellite replied. Next, please. That's again J8 DJJ. J8 DJJ station. Multiple Yagis, all kinds of fun stuff. I sent him a long letter. I said, "I envy you. I will never be able to get to this position." Next. Sorry. This was when I was in Kharagpur, yes. Oh, that is in Japan. That is from this Japanese station which I talked to. Okay, that was my 1, 2, 3, 4, 5, 6 element Yagi. Actually, it's 7 elements. The 7th element is through the roof. And I used the old Armstrong method of rotating with me standing behind it, one key in one hand, headphones. I don't know how I wrote the contact down, but that was me when I moved over to, when I started working for the Ministry of Defense. So from my house. Next. This was in Kharagpur. This antenna was stuck out through the window. So obviously, there was a guy behind there who was cranking it forward and backward. "Hey, the signal's too low. Let's move it further this side." It's too low. It was fun. Those are, again, all pipes all soldered together. And basic point is it worked. And that's all I care about. Next. Okay. This is my good old days when I was fooling around the telescope. Next. Now, next. Okay, then you can shut it down. Any questions? Any questions from anyone? If you are interested, I have full drawings of the Morse key on PDF format. Feel free to duplicate it if you would like. Or I have full drawings of the rotator and what have you. Oscar 6 downlink was 29.5, 29.45 or something like that. Yes. And they've just sent another, the CA5, the Chinese thing. which has just gone up. What is the Chinese satellite? CS5, 5A or 5B or whatever. I think it's, yeah, there's a 21 up. That should be relatively easy to work. Thank you.
Yeah, let's give Arun, that was a very interesting talk. Let's give him a round of applause. And
Oh, thank you.
this is a token of this thing from LARC. Thank you so much. Okay. Thank you, thank you. The next session we have is Farhan. So there's no need of any introduction. Thank you so much.
Can I just put that here? Hello. Thanks, miss. Okay. What I'm going to talk about today is a little different from my usual projects, which are very big and complicated, etc. So we basically at the club, and a lot of people have been talking about this as well, that we need some radios for the newcomers, whether they are already licensed or not licensed, etc. So if you want them to experience radio, see earlier what would happen is, like, when I became a radio ham, I knew so many radio hams myself, and I would sit with them and watch them operate, etc. So I knew what the band sounded like, how to tune, etc., even before I became a radio ham. But now they get licensed, but they have never actually experienced ham radio in particular, right? And they get this license and they forget about it and it's all done. So if there is a simple radio receiver which is easy to build, etc., etc., and so what all it should have, we'll talk about that. So the club took this project up, and to prove that it works well, what we did is that we went with a bunch of 35 girls between 9th and 11th standards who actually build these radios, and it works very well. Okay, so I'll do it myself. This is what the radio looks like. Okay, it's very odd looking radio, but I'll tell you why it looks like what it looks like. It's very interesting. That, yeah, ma'am, next one. It's a radio receiver which can be produced, and I'm saying produced, not built. Produced for 100 rupees. That means even if you commercially produce it, for 100 rupees, we can build a radio which can be given away to students, to people who pass things, etc. Or even, for example, in LARC's kit, for example, probably next year's LARC kit might actually have a full working radio. So how do you get to a radio which costs only rupees 100 to make and produce? So actually the bill of material should be even less. The bill of material should be less than 30 rupees if you are thinking that, you'll be able to produce it for such an amount. Okay, so that's the challenge. Ma'am, next. Okay, so the thing is that, once again, no, I think there is, no, okay. So the challenges of homebrewing radios are many. And the first one is, how do you do the tuning? Okay, tuning is a big problem because variable capacitors are no longer being manufactured. And the moment you ask for a digital tuning system, what happens is, it's very expensive because you require an LCD, you require an Arduino, you require something like SI5351. Now if you just put them together, the cost itself is about 600 rupees. More actually now, Arduino is almost 400 rupees Arduino is 400 rupees, 200 rupees for display, another 200 rupees for SI5351, then an encoder. That itself becomes 1000 rupees. So if you're going to build an analog radio, you cannot build it with digital means. Okay. Now you say, fine, we'll build an analog radio. The problem with analog radio is, one, it drifts a lot. And if you remember earlier, you had really big masters, like Arun and Rao, who they say, they've built an oscillator which is rock stable, it does not move at all, etc. Okay. So the main ingredient of making an oscillator very stable is actually the quality of components. It is not about how good an engineer you are. Because the frequency drifts because it gets hot. When it gets hot, the capacitance changes, the inductance changes, etc., etc. So what you need to do is, you need a design which works very well with ordinary components, number one. Number two, what kind of tuning mechanism will you use? Because variable capacitors are no longer being manufactured. Nobody listens to radios. Even if they listen to radios, those plastic capacitors, some of them are available, not many are available. So for example, like today, 550 people are here. If we have to produce 550 sets, we cannot do it using those capacitors, because that many variable capacitors will not be found in Hyderabad. And we need a design where these components are freely available in any town across the world. You should be able to just go resistors, capacitors, transistors, and build it with that. Okay? So we have a very tough list of things to do and how to build it. So here, if you see that what you see here or here, it's a 3D printed part. It's very simple. It's just a coil, right, if you can see. But the interesting thing is what you see here and here, which is there is a nut inside it. There's a brass nut. And that actually takes a brass screw. Back. There. So, as this brass nut keeps going inside and out, it changes the inductance. And because it's threaded, the tuning is very slow. It's as good as any Yasu or Kenwood of the old ages, right? Like TS520, that kind of tuning. It gives about 20 kilohertz per turn. This kind of thing, number one. And you see that, instead of putting up a knob, the knobs are actually costing 40 rupees these days. I've used a door stopper. So you just, super glue a door stopper to it and it works. And it's very stable. It's extremely stable because it's essentially air core, inside the 3D printed thing. If you don't have access to 3D printer, there are other ways of doing it where you can, for example, solder the brass nuts onto the front panel, two of them, two panels, and through that also you can do that. So that was the whole concept. So we first started by building the oscillator itself, okay? But if you see what a simple receiver is, there is an antenna, the detector converts it into audio, and there's an audio amplifier. That's the simplest receiver possible. Now, the earliest receivers made for radio amateurs or other people were called regenerative sets, which did this. But they drift a lot. They're extremely difficult to tune. So a lot of people keep saying, oh, you're a beginner, you should make a regenerative receiver. You may be able to make it, but it takes a lot of experience to tune a regenerative receiver because it does all sorts of things. If you try tuning the frequency, the amplitude changes. If you try changing the amplitude, the frequency changes. Everything is related to each other. It doesn't work at all. So what you need is a direct conversion where you basically add an oscillator. So whatever frequency is coming in, let's say, you are doing the CW net at 7020 with Ganesh, right? So the oscillator will be slightly out of that frequency. If this is 7020, it will be 7019. 7020 minus 7019 will be 1, which is 1 kilohertz. So an audio tone is generated, which is amplified. So it's as simple as that, okay? So instead of 2 stages, now we have a 3-stage. But because ma'am, can you just go back to the old one? Yeah. What's happening here is through this antenna, all signals are coming out to the detector. The detector is not a Superman that, it can handle all signals simultaneously. You need to first filter out to only band of your interest, okay? So what you do is you add a, I'll do it, don't worry. You have to add a filter. So you have a filter detector, which is actually a mixer, an oscillator, and an amplifier. Okay, here, I'd just like to, tell you this, that unlike other parts of electronics, in ham radio, you have to know only 4 types of circuits. Okay, in fact, just 4 circuits will do. You can keep repeating them over and over. One is an oscillator. If you can make an oscillator, you can make a BFO, you can make a VFO, you can make an up converter, down converter. Everything is possible if you know how to make an oscillator. Filter, filters, mixers, and amplifiers. Those are the only 4 blocks that are used to make any kind of audio radio equipment. If you can make these 4 types, right? And a direct conversion receiver has just 1 of each. Okay, so this is the this is the oscillator. Very simple. Okay, and here what this inductor is the one that you saw, which is air inductor with a screw through it. And there are 2 capacitors here. These have to be very good quality capacitors. You know, so the point is, if you use more capacitors, you need to have more of good quality capacitors. We could have done with even 1 capacitor with a tap on the coil. But for beginners, to make a coil with a tap would have been difficult, so we chose to go with 2 capacitors. Now, these are called Styroflex capacitors in India. They are called polystyrene capacitors abroad. They are not very rapidly available, but even in Hyderabad, there are 5 or 6 shops which has got thousands of them in bags. And they cost about 1 rupee each, you know, which is a little more expensive than the regular capacitors, which cost about 50 paise each. Okay. Someone here? Venu, just get me some water, please. So, now, if you see that this is what determines the frequency, okay? But apart from this, there are just 3 more resistors and 1 for the power supply. Oh, we've got it, thanks. Sorry, I have a cold and the throat is very sore. So, we've tried keeping down the number of components as few as is possible. And the other idea here also is that you should be able to very quickly build this yourself even without a PCB, as I've built it here. Now, if you see that there are other things here at play, for example, this is not a field effect transistor or a MOSFET or whatever. It's a simple 2N2222. You can put any transistor in it, it will work. 2N3904, it has worked. BC547, it will work. Everything will work. Even AF115, if you have an old one, that will also work here. Okay, all of them will oscillate. All of them will oscillate well. Okay, and very stably. It's so stable that when I'm using a radio with this, I can actually decode FT8 very easily. Repeatedly, it works. Yeah. So this is what the tuning mechanism looks like. It's fairly simple. So actually, there is a nut here, and there's another nut here. It's a 1/4-20 brass bolt. Now the key thing is this. It has to be a brass bolt. It cannot be anything else. You cannot put, you know, any ferrous material or whatever. Brass, and brass has a very weird property. How many people here have tuned RM96s? Can you raise your hands? 1, the RM96, 2, 3, 4, 5. Yeah. So you see, for the frequency, when you put the slug in, the frequency, you know, decreases. Here the frequency increases actually, because it's brass. So the inductance comes down when the brass goes into the core. So when you actually rotating it like this, okay, the screw is going in, and as it's going in, the frequency is going up, which is exactly how the other radios work. So if you put ferrite or something, firstly it's very lossy, but the most important thing is that the tuning will be in the reverse direction. So which is by this. So that's the completed VFO here. I just spend a little time in VFO because it's the most important part of a radio. But this is the whole circuit. So I'll tell you, you know, what is special about this. First, there is a band pass filter here. Okay. Now, the thing is, if you do not have a band pass filter, you will have everything from Vivid Bharati onwards coming into this, and you'll be able to listen to AM broadcast, although you are not interested in the AM broadcast, right? Because it will just go through the circuit. So you need to put something which will cut off the medium wave broadcast, as well as the FM broadcast on the other side, okay? So you need something which is band pass filter, but being a direct conversion receiver, it doesn't have to be very sharp. If you make it very sharp, then tuning it becomes a problem. So this does not require any tuning at all. it has a peak which is almost 2 megahertz wide. So even if you miss out a turn or two, you can make it. The other advantage of this is that using such a low Q bandpass filter also makes it possible for you to use just about any kind of inductor, as long as you can get this value, okay? It's, I think, about 2 microhenries. So you can wind it on a PVC pipe. You can get a 2.2 microhenry inductor from the market. All of them will work, okay? So there's no problem there at all. So actually, in the entire receiver, there are only 2 coils, this and that. There are no trifilar coils to be wound, no need for toroids, no nothing at all. Which is why it's a beginner's receiver, because it's also easy to make. Then this stage mixes this, the local oscillator and the incoming signal to produce the audio. And this is actually not an amplifying detector. So basically what happens, if you see, is that the oscillator is fed to the base where usually the signal comes in. But what it does is, effectively, it switches this transistor on and off. That's what it does. It rapidly switches it on and off. So it's actually a switching detector. Although it's made out of an NPN transistor, again, which is very easily available. I mean, these transistors cost about 50 paisa each. So what happens is, now that you need gain, you have another NPN transistor which will amplify this. And if you see that there are these capacitors all over here, okay, these 3 capacitors together form a sort of a low pass filter, which makes it very sweet to listen to. And then you have an LM386 as an audio amplifier. I thought that even instead of LM386, we can even have a discrete amplifier, right? That is with more transistors, but that would have meant more soldering. This can be actually, this entire thing was assembled by these girls over 5 sessions of 1 hour each. But that is because we were also telling them what to do. They had no idea of how to solder. Some of them were not even interested. So, you took a little time to, goad them into this and for them to build it. But finally, each group of 3 girls built this entire thing, themselves. And all of them are working. This is a picture from that workshop where they are actually building their sets. Just with hand tools. They never had access to even an oscilloscope while working with this. They learned to use a multimeter. So if you consider this, the kit that was given to them is about 500 to 600 rupees. A cutter, plier, screwdriver. And if you see that there are no power supplies, they're using batteries. That was another thing. This had to have very low current consumption because you don't want the battery to run out very fast on them. I mean, if the battery is running out every 3-4 days, they again go back to their parents or whatever, ask for more cells, and they say, buzz off, what's all this? So this battery will last them for at least 1 to 2 months of continuous coverage, right? So it had to be very low thing at all. So next one, ma'am. That's their end thing. I think because each was a group of 3, so they actually produced 9 of these radios. All of them are working. I have got some of them here, and the radios with me. You can, after this speech of mine, you can come and see. So this is what we have done. So next steps. There are a lot of PCB, gurus here. There is Sophie. I think Charu will be somewhere sitting here. Oh, there is Charu. So, I hope to get some of these people interested. It's actually very simple. Hopefully we can lay it out as a single site PCB, And at this time I'm really missing my friend Rahul, who jumped to this, who, built the first PCB of BitX. So, if it was not Rahul, it will have to be one of Rahul's friends who will pick up the slack there. Second thing is, I thought that it should be a balanced mixer. The detector should be a balanced mixer. But, it's how simple you can make versus how good you can make. So you have to draw the line somewhere, and having a trifiller coil, etc., that was one way to go. Other is to use something like NE612, but do it in discrete devices. At least 3 transistors would go instead of 1, which is 2 transistors more. So I was not very, convinced that we should have that extra complexity for a beginner's receiver, because it's supposed to be very easily made. So that's the thing. Third is to produce kits out of it. This is a club project, okay, by the way. I should mention this, that this is not my project. Okay. The PTO design is completely due to RK, who's here. He's the one who designed that. The rest of it, I designed parts of it. Sashi contributed, Thomas has worked on it, etc. So this has been a team project. And we hope that we'll be able to, get kits out for that from the club side. They can be, semi-built kits. For example, you can take an SMD thing and produce SMD parts, and then you put the coils onto it. Or we can just give the PCB with parts, or give completely, working radios. So either way, it's possible to do that. And these radios can be really, put into any box. Better to put them on a box. I have the radio in a couple of boxes here. So that's it. Thank you very much. Any questions? I'm willing to take. The 6th class kids they have not practiced maths enough to quickly figure out what I'm saying. Okay, so I say there's a 2.2K and a 2.2K, so the 12 volt becomes 6 volts, then 2.2K, 6 volts, so you expect about 3 milliamperes of current. But I'll just rattle it off. Yeah, 8th onwards. There were not one school. This was done through the Women Entrepreneurship Hub. So there were a number of schools put together. Yeah. Sophie, on this one, I put about 18 turns. Yeah, of 22. So the complete 3D file is there. I'll just upload it on to the LARC website. Okay. So, yeah. Sudhir. Well, it's very sensitive. There is nothing that it will not receive which an IC 7300 will receive. Having said that, because it's direct conversion, you have an image problem. So, for example, when you are on 7078 for our 7080, right, Belgaum net. So when you are receiving Belgaum net, there is somebody else who's talking at 7083, you can listen to them as well. Because the image is there, audio image. So that is the first problem. Second is, in the early evenings, at my location, radio peaking comes through. So evenings are written off for me. We actually have an antenna there. So we can switch on the radio and you can actually see the performance yourself. Right, so that's that. Okay, so I think that's that. Next session is Sashi's, right? Just call him if you. Bill is not coming. Bill is not in. Just open that box of mine there. Arun, just give him that box, yeah. Oops, careful. Just open it. Yeah, that's all. Yeah. There's a power, there is a battery also for that. No, there's a battery right there. Yeah. So I have one version of it here with me, and it will be available on the table there. You can actually, see how it works there. Sanjay, take it there and put it on so for others also. No, take it there. Yeah, you can play with this. So because we've already I've built 3 versions of this, and the girls built another 9. It's a fairly stable design. It works very well. And it's very simple to make, really simple to make. Now I can make one in half an hour. In fact, I was not well for the last 2 days. I thought that while talking to you guys, I can build one and show you. I can build it in half an hour. from scratch, including winding of the coils, I can do it in half an hour. Yeah, it's already done. It's already done that way. There are actually videos I have of how to do this. So we have actually, I'll show you. Actually, it's very detailed. So, for example, I'll show you the way we have done this. So you see that this is the first day's work. So each step we have detailed it separately of how to cut, solder, take each component, solder it, second component, third component, like that, right? So it's a very detailed thing that we have. And I'm also showing, what is what. For example, a Zener diode is usually put upside down. So it's counterintuitive as to how you install it. See, that way. So they know what they're building all the time. How to tin the wires, put it up, check the voltages at various places, capacitors, which is which. So that's been actually done in fair amount of detail, and what the final waveform looks like. I'll just see if I have some videos to show you here of this. Yeah, not this, next now. Yeah. Okay, this is showing how the thing is soldered. Hang on, no, not this. Probably this. Anyway, it'll be boring to see those videos right now, but we have very well documented, all over the place. So that's how to. Yeah. And the thing is, this is all simple components. Actually, you can buy all these components from behind here. Yeah. So the instruction sheets, instead of printouts, they will be YouTube videos. So that, they can just see that and follow it. Okay. Acha, now, we have been unable to get through to Bill Miera. The next speaker who was supposed to be here. He was here last year. He runs the Solder Smoke podcast. I hope he's fine, because I tried reaching him last night as well and I couldn't reach him. So I don't know what's going on in Bill's life. So we are not going to have Bill today. Tomorrow we will, at the same time, we'll slot him because it's morning at his place and he's a morning person. So we will probably, get him in tomorrow evening instead of today. So this is the last session here today, but we have more sessions happening in the other hall if you would like to do that. And for those who have not had it, there is mirchi bhaji and samosas available with tea and coffee outside. So please go and have it. Most importantly, this is a time for you to go for the flea market and attack and buy everything which is inside. Thank you very much.
Thank you, Farhan. Let's give Farhan a round of applause. Farhan. So we will finish for this day. Those of you who want to go and take a look at the flea market, you can please go ahead and there's some sessions going on in the seminar hall. You can also go there and see. But the sessions here has ended today. Thank you so much.